So I know we got 10 minutes of class left, but I really want to finish this Nagishi section. So if you look here and here.
Professor, can you zoom out?
Oh, yeah. Now, if you look here, we have this bond formed here. It's a carbon-carbon bond, and you notice these two are not in the end. We can just move on to real-life orgo now. We've got a really good real-life orgo for you guys this week. We're going to do the fermentation of foods and beverages. This is a really good one. I wouldn't recommend missing it. Hey, where are you going? We got a good real-life orgo. You're going to miss a really good real-life orgo. So for this week's real-life orgo, we have some mediocre guests from last year's chemistry class. Caitlin Buck is here to introduce the topic that we're talking about.
Alrighty. Okay, so thank you for the introduction. Like he said, today we're going to be talking about fermentation. Now, fermentation is both a biological and chemical process, and it's important in both aspects, which is why we're talking about it today for real-life orgo. Now, it's a pretty old process. We're talking 10,000, maybe even more years that we've known about it. And it's responsible for a lot of really important products that we use on a day-to-day basis around the world, especially during Grand Prix week here at Purdue. Okay, so now that we've talked about the overview, we're going to start to jump into a little bit of the history of this whole process. And
like Caitlin said, fermentation is pretty old. In fact, the oldest evidence of an alcoholic drink comes from around 7000 BC. Historians' best guess at how fermentation was discovered by humans dates back to the time of hunter-gatherer societies. They think that while out on the hunt, a member of the tribe might have found a wild beehive and collected some honey in their water pouch. On the way back home, wild yeast in the air and their pouches fermented the honey water. Once people drank it and got drunk, they thought it was magic. Along with making people drunk, fermenting drinks has a lot of uses. In a lot of cultures, people actually had to drink alcoholic drinks because it was cleaner than their water. We'll get back to why that's true later. But first, let's talk about fermented food from around the world.
Fermented food can be found throughout the world, with each culture spinning the chemistry to fit their desires. In Asia, you can find kimchi, pictured here, which is made from salted and fermented vegetables. This staple in Korean cuisine has hundreds of varieties, with different vegetables being the star of the dish. If vegetables have you screaming in terror, then maybe sake is more suited for you. Although you'd have to be 21 in the States to enjoy this rice wine, you can be sure to see it all over Japan. If you travel to Europe, be sure to try prosciutto, which is a fermented meat originating from Italy. Get there before they run out, because it can take 9 months to over 2 years, depending on the size of the ham, to make more. Although many think only Vikings consume this fermented honey drink, Europeans still enjoy this golden-colored liquid. Next on our adventure, we're stopping by Africa to pick up some oil seed. These fermented seeds are turned into an oil that can be compared to vegetable cooking oil. If you're on a no-oil diet, then perhaps a big bowl of millet porridge will suit your fancy. This hot dish is made by crushing the millet plant shown here and allowing it to boil before allowing the mixture to ferment. Lastly, we travel back to the Americas, where people can be seen shopping for beer, unless it's Sunday and you're in Indiana, of course. This beverage is usually the first drink that comes to mind when talking about fermentation. The last food we'll discuss is bread, which is loved throughout the world for its light and airy texture.
Local or global, fermentation is always facilitated by yeast and bacteria. It starts with glycolysis, which is a pretty convoluted biological process, so we're not really going to go over that. However, in the creation of alcohol, pyruvate here, it's oxidized by pyruvate decarboxylase and becomes acetaldehyde. And at this point, the coenzyme NADH reduces the acetaldehyde, and in an acidic solution, the resulting molecule is protonated to ethanol. Additionally, acetaldehyde can be oxidized by NAD- to acetic acid. This is generally undesirable for alcoholic beverages, but certainly desired for creating things like yogurt.
Yogurt and kimchi are poor probiotics due to the fact that bacteria we use in the fermentation process. That bacteria is itself a probiotic and remain alive, generating the yogurt to production, and all the way until it gets to your tummy. Ethanol kills bacteria by dissolving bacterial cellular membrane. Bacterial cell membranes are similar to a soap bubble. The outside is hydrophilic, polar, and the inside is hydrophobic, non-polar. So when ethanol comes into contact with the bacteria, it can dissolve the outside of the membrane and the inside with its polar alcohol group and its slightly non-polar carbon chain.
Okay, so like we talked about before, fermentation is facilitated by the presence of bacteria. Now when these are consumed, the bacteria that's contained within the food that we're eating travels through our digestive system and collects along the stomach and intestinal walls. These bacteria can survive in harsh acidic conditions such as stomach acid, which has a pH normally ranging between 1.5 and 3.5, which we know from previous lectures is a really strong acid. These bacteria are essential to introducing vitamin K to the body, which is one of the only groups of vitamins that are actually produced and recycled within the human body, but not by the human body itself. Now, vitamin K is a group of organic compounds involving cyclic carbon rings, ketones, and in many cases, long carbon chains. The vitamin K molecule aids in carboxylation mechanisms of glutamic acid. The molecule itself goes through a series of oxidation and reduction reactions in order to recycle and reuse molecules. Reactions with the molecule glutamate result in an epoxide product too.
The fermentation methods to create ethanol and lactic acid are both types of anaerobic respiration. This is a fancy way of describing how an organism harvests energy from sugar without oxygen present. Lactic acid fermentation is not only responsible for yogurt and other similar snacks, but is also what occurs when you feel that burning sensation during a workout. This type of fermentation is occurring in your muscles. Lactobacillus is an organism prone to anaerobic respiration in the form of lactic acid fermentation, even in the presence of oxygen. Similarly, yeast strains like Saccharomyces are prone to anaerobic respiration in the form of alcoholic fermentation. When you drink alcohol responsibly at the age of 21, the ethanol is converted to acetaldehyde through an enzyme, which is then converted to acetate. The acetate can then be further broken down into carbon dioxide and water. The acetaldehyde has been linked to symptoms and hangovers, which we talked about in a real-life orgo many months ago. Did you know that in 1789, George Washington gave away around 140 gallons of hard apple cider to his supporters the day before his election? Wow, that's an amazing fact. Did you know that in the time of the kings and castles, servants were often paid in sizable rations of hard apple cider? Can you believe it? Did you know that a cup of yogurt can contain anywhere from 90 to 500 billion living probiotic bacteria at the time of purchase? That's a lot of bacteria. Did you know that the image we conjure of a witch stirring a concoction in a pot with her broomstick originates from brewsters of long ago? Brewing alcoholic drinks was once mainly done by females at home, using a large black kettle and a broomstick to stir. Isn't that just amazing? Did you know that it is estimated that the nearly 1/3 of the average person's diet is composed of fermented foods? 1/3. Can you believe it? Did you know that at any time it is estimated that 0.7% of the world's population is drunk? Let's all hope they're over 21. Recall when we recalled bread making, when we recalled the Maillard reaction. Different flavors can be incorporated into the foods via these few molecules. Some shift bases found in the Maillard reaction can also be found during fermentation. And that's all we have for real-life orgo fermentation. Thank you for actually staying.